All right, everybody, thanks for tuning in to another edition of the Daily Space Weather. I'm your host, Dan, aka smAsho. Today we'll be talking about a plausible explanation for why the geomagnetic storm and, so far, lack thereof was such a dud, as well as all the rest of the relevant and pertinent data. Here's a one-day SDO video of the local yellow dwarf, otherwise known as El Sol. This is in 193 angstroms. We see one sunspot approaching a setting mode in the southwest of the solar disk, a series of coronal holes in the northern hemisphere, just above the equator, I guess you could say at mid-latitudes, and a basic lull in solar activity right now. The 10.7 centimeter radial flux is down to 82, and there's a one-year graph of the radial flux, which we use as a proxy for sunspot number. It's great to see at times of solar minimum the radial flux, and you can see how proportional that is to the sunspot number progression. Those are images of the last solar cycle and the beginning of this one. Welcome to the Neo-Renaissance, cycle 25. Next, we'll take a look at the view from Lagrange point 5 at stereo A. I thought we would. There we go. To show no Earth-facing coronal mass ejections, but the possibility is still there, folks. So you see all this plasma out here. That's the corona. The Earth is out in this direction from there. That could release at any moment, and keep in mind, we don't need to see a solar flare in order to see a coronal mass ejection. Let me go back to where I was here. And thanks for tuning in and leaving a comment. Sinichirama. All right, so we're on HelioViewer now. It's helioviewer.org. And I'm unable to make any HelioViewer movies right now, but I'm going to use the HelioViewer viewpoint to explain something about why, one plausible explanation of why the coronal mass ejection was such a dud. So, what went on here with the coronal mass ejection is two things happened at the same time, folks. First of all, we saw a coronal hole wind stream coming out of the northern portion of the sun. So let's just say this is the coronal hole wind stream. And we're going to oversimplify this to make a point. The coronal hole wind stream is sort of a stream, and the coronal mass ejection is like a cloud traveling at a high speed. Coronal hole wind streams have a polarity. The polarity out of which this coronal hole wind stream came was South Pole polarity. The umbra from which the coronal mass ejection came was also South Pole polarity. And what could have happened here is, as the coronal hole wind stream was headed toward Earth, the coronal mass ejection caught up to it, and it could have pushed it probably to the north as the coronal mass ejection struck the Earth. So, you know, these are both South Pole polarity. They may have exerted a repulsive force on each other. If we see a coronal hole wind stream with the opposite polarity, these things can actually combine and form into what we call a co-rotating system. And they can actually accelerate each other and cause all kinds of different sort of effects. But I think one of the plausible explanations that we can put here as to why the forecast for a geomagnetic storm was such a dud could have plausibly been the similar polarity of those two systems. Speaking of polarity, here's a colorized magnetogram. And we do see an active region up here. I'm not sure if that formed any umbrae or not. It's about to set anyway. I don't see any sunspots besides this one down here. And we'll show you a high-res image by the end of the video. Also, this active region over here in the southeast does not appear to be a sunspot. So again, there's stereo A that's located at Lagrange point 5. And I wanted to show you one of the possible things that can happen when we do see a coronal mass ejection, or indeed a coronal wind stream strike, is we see induction in the U.S. power grid. So one of the links that you can find at the Space Weather Enthusiasts dashboard is this empirical data. And this is showing you millivolts per kilometer. And this shows you the possible induction in the power grid. Of course, there probably was some created. And if you're in a Western nation, it's quite unlikely that a coronal mass ejection of this magnitude would cause any sort of disruptions in your power. Now, they can cause communications errors. We are expecting an increase in the electron flux, which we'll cover later in the video. And that can shut down all kinds of satellites and cause all kinds of communications and GPS problems. But as far as induction in the power grid, this is one of the data points that you can use. And you can see there is some induction in the power grid. The geomagnetism on the Earth is slightly heightened right now. We only ever saw a KP index of 4. We'll get to that momentarily. So perhaps check this out next time there is any sort of a strike on the magnetosphere. This one is called Geoelectric Field 1 Minute Empirical Model. And there are a couple other similar models here that you can see down on any of these Space Weather Prediction Center pages. A whole series of links down there. Hopefully that helps you new viewers to understand sort of how that works. The power lines can get inducted electricity in them because of the radiation coming from the sky. So that can charge up the power lines, and it can create more current than would be expected by the output of the power plants and the usage of the end users. Here's another solar disk view. It's another one-day view here of the sun in 304 angstroms. And again, there are a lot of filaments in between us and the sun right now, and there could be more coronal mass ejections coming. Part of the reason why we have a channel. We cover it daily. And if you don't look, you certainly won't see it. Just bear with me one moment. We are streaming live. I would like to invite everybody to view our Smash Lights playlist. So we do have a series of playlists at youtube.com/smashomash/playlists. So check that out, as well as there's cosmology segments, scrying with Smash, the diamond anvil too hard to smash, terms to find, a whole bunch of different playlists you may like to check out there. We've also got a Facebook group called Entropy Busters, and it's, again, part of the reason why we have a channel. We're out here busting entropy on the daily. And we've had many attempts at gaslighting, which is all in good fun. Gaslight away, or attempt to gaslight away. Pro athletes aren't affected very much by that. We're also on Twitter. Check us out there. And we'll probably make another video today. Speaking of making other videos, we'll be streaming live at the moment of the solstice this year. Where will you be on December 21st at 5:02 Allentown time? I'll be streaming live. It'll be a YouTube exclusive. And thanks to everybody viewing in all the different locations, whether you're on Twitch, etc. And if you're on YouTube, please take a moment to press like and subscribe. Share the videos on your social media, as we need your assistance to reach 1,700 subscribers. And thanks to everybody viewing the content over there. Thanks new subscribers, everybody leaving comments, etc. We do read all the comments. Again, we are on BitChute. There are some exclusives there. And once again, we are streaming live today to Twitch. It's twitch.tv/smashomash. They've got a great mobile app. It will even notify you when we've gone live. We don't always stream live to Twitch, and I'm not the most interesting man in the world. But when I am, I drink beer. No, I don't. Now, Sugas, shout out to Sugas of Deutschland, aka Germany. She asked us for a Discord channel, and we've already got a Discord channel. So if you want to link to that, you need an invite, and we've placed a permalink, thanks to Smash staff for doing that, to the Discord channel with our social media links at smAsho.com. So head to smAsho.com, consider becoming a patron. You can see the Twitter page, PayPal, Minds, the Facebook group. We've got a locals page, smashamash.locals.com, Instagram, etc. Also visit the links down here, the smAsho forum and the stores. Today's featured product is the Are You Safe Yet mask. Yeah, you've got to wear one. You might as well go around asking everybody if they're safe yet. And me being a clothing wonk, because, well, pro cyclists express ourselves via clothing, especially socks. But in any case, go around asking people if they're safe yet while wearing our Are You Safe Yet mask. I think you can still get it in time for Christmas if you'd like to give it out as a gift. And I've made this in these colors on purpose, as the black doesn't show dirt, but the white lettering does, because you don't really want people walking around with a ratty face mask on. You can link to all of that. That's at the smAsho store. There's also a Smash store, which has differently themed items there for your purchasing pleasure. And don't forget to enter the promo code smAsho on all orders through Christmas. We'll keep that up until the day of Christmas. And save 10% at checkout. Again, on all orders at Teespring. Again, we'll be making another video today, and we're going to go on a quest today in today's cosmology segment. A quest for what? A quest for a random number. So I'm going to use this quantum random number generator. And today's random quantum number is 270. Now, these are the transient X-ray outbursts from Cygnus X3, which is not number 270. We're going to go back to the Neil Gorell Swift Burst Alert Telescope Observatory and go have a look at what's going on at number 270, which is a high-mass X-ray binary / neutron star known as GS0834-430. There are the X-ray transients, and check it out. This is an interesting one, as in 2012, which is probably how it got on the list. It had a massive X-ray outburst, which is something like 60 times the normal outburst, the normal X-ray output profile of this, which is actually quite consistent, except for at that moment, mostly. So that's an interesting one. The high-mass X-ray binary GS0834-430, a catchy name. And there's the daily and the 30-day output for that. We don't seem to see that one on Simbad, so we'll leave that alone. Perhaps you want to do more reading about that object, feel free. I wanted to also note, while talking cosmology, about the Thermosphere Index. So, the Thermosphere Index at solar minimum becomes the coldest that it gets. You can see how proportional that is to solar cycle. And you can see how much colder the thermosphere was at the last solar minimum as opposed to the recently ended solar minimum. It's practically already back into a cool zone instead of a cold zone. Another indication that the solar minimum isn't that grand. So this is an important factor, as this is, the thermosphere is sort of the outermost aspect of the atmosphere. Well, I guess you could say besides the exosphere, which reaches all the way to the moon. I won't get into that in today's cosmology segment, but that is an interesting piece of data. You can show people that graph. It's linkable at spaceweather.com. Next, we want to take a look at cosmic rays. Since cosmic ray flux was higher in 2010 than it is now, just like the thermosphere was colder, let's take a look. Here's the Opacity Neutron Monitor, which shows a downtrend over the past 30 days. Here's Barentsburg, which shows some interesting spikes here, but still a similar downtrend over the past 30. Next, we're going to go farther south, and then much farther south, to the Athens Neutron Monitor. And there's the Athens Neutron Monitor, a bit more flat over the past 30 days there at Athens. Next, quite a bit farther south to Mexico City. Precipitous downtick in the past day or so there at Mexico City. And a slight downward trend over the past 30 days, but mostly flat at Mexico City. And this is one of the many cosmic ray monitors where you can look up the older data and show obviously that cosmic ray flux was higher in 2010 than it is today. Lastly, looking at Oulu, Finland, and DOMC, Antarctica, there's Oulu, which is slightly down over the past 30 days, but mostly flat. And here's DOMC, Antarctica. Downtrend there over the past 30 days as well. DOMC and DOMB, Antarctica is not sending data. So yeah, don't take our word for it. Monitor them yourself. I like to use this Network of Cosmic Ray Stations site. And there ends today's cosmology segment. Let's get back to the daily space weather data. And we'll look at the real-time solar wind, a regular feature here at the Smash News Network, which is, oh gosh, it's burning again. Please consider becoming a patron so we can afford more fire extinguishers. It gets tiring putting it out that way. Patreon.com/SmashoMash. Official crowdfunding source of the Smash News Network. And here's the real-time solar wind. And here is the coronal mass ejection strike, which already looks like it's subsiding. And we barely even got to 600 kilometers per second for the speed, and barely got to 20 protons per cubic centimeter for the density. Current conditions are solar wind density around 10 protons per cubic centimeter. Solar wind speed still elevated at 487 kilometers per second. And there you can see the KP index all the way back down to 1. And for new viewers out there, the KP index is a global geomagnetism measurement. NOAA was forecasting for a KP of 7. I don't think that's going to happen. What say you? Leave us a comment if you have a theory. So here are the Geospace Magnetosphere movies. We're going to show you all three. First, the velocity, which again, while elevated, is not producing significant geomagnetic effects. That's 4 hours of data. Next, we'll show you the density. And there's the density. And by the way, if you understand the physics of what you're looking at here, you can just look at these and make an educated guess as to what the solar wind speed and density are. I do it daily. It's part of the way I stay in practice. And probably most of our viewers would be able to do the same. As if you immerse yourself in the data, you may start to understand the relationship and indeed the physics. Let's hope. Lastly, the pressure. And you can see we still do see an elevated pressure. A little bit of a sputtering happening there. Next, we'll show you ground magnetic perturbations. And we still do see quite a bit of ground magnetic perturbations. Here's that. There's the global view of that. And we see magnetic pulses coming out of the Pacific Ocean, the Indian Ocean there south of Australia, which is where the South Geomagnetic Pole has migrated to, thousands of miles away from the South Geographic Pole. We do see significant magnetic perturbations there over the Canadian North Pole, less so over the Siberian one this time. And if you're wondering why I'm talking about two geomagnetic North Poles, it's because we have two geomagnetic North Poles. The net North Pole is someplace between Svalbard and Greenland. Here's the view from the poles. And when we see more significant coronal mass ejections, coronal wind streams, etc., it gives us an indication of where the geomagnetic poles are located. And you can see some evidence there of the geomagnetic South Pole being in the Indian Ocean as opposed to over the continent of Antarctica. Next, looking at the auroral forecast. and it's kind of small, but you should be able to see the timestamps and so on there. The main strike of the coronal mass ejection was at around 20 after 2 universal time. That's 0220. 0220 universal time. Since then, the whole situation's been weakening. And I think a deflection of the coronal hole wind stream by the coronal mass ejection is a pretty good explanation. What say you? Leave us a comment. Next, the proton flux. You can see this has subsided quite a bit. We saw the second proton event right after the first one here in cycle 25, and we haven't seen any of those for years. There's the 3-day chart once again, and we see some crackling of X-ray flares here, nothing big. Not even a C-class flare here over the past 3 days. Here's a star chart, and everybody's getting ready to watch Jupiter and Saturn converge. If you're up before dawn, you may see the Moon and Venus. Venus being the third brightest object in the sky. And I believe Jupiter and Mars trade places for the fourth brightest object. Leave us a comment if you know whether the Jupiter-Saturn alignment will be brighter than Venus. I think it'll still be less bright than Venus. And somebody's theorized that the original Star of David associated with the birth of Jesus was indeed the convergence of Jupiter and Saturn. And there you can see this straight line forming between Earth, Jupiter, and Saturn. I like to use theplanetstoday.com for my solar system visualization. There's where we expect things to be in a week. As we get closer to the solstice. The GOES magnetometer is looking a little more normal here. For you new viewers, the N's and M's mean noon and midnight time, local time for the GOES 16 satellite, which measures the magnetism at the F ionosphere layer. Next, we're going to look at the magnetism of the current sheet, the heliospheric current sheet. Now you're looking at the sun from the top view ecliptic plane field plot, part of the National Sunspot Observatory. This is one of the most important items that we use for solar forecasting. And the Earth is solidly in the North Pole current sheet shown here in green. Expect some more fluctuating readings from the GOES magnetometer in the following days. Again, there is a lot of plasma in between the Earth and the Sun right now, all out in this area, as we showed earlier from the view at Lagrange point 5, the location of stereo A. Here's the line of sight coronal hole field plot, showing you the B field in blue. B field is the field that goes through a magnet. And we see a bunch of North Pole oriented coronal holes here in the northeast. And there's the view including the poloidal fields in green and red, the north and south solar polar fields, as well as the magnetogram. And last but not least, we'll look at the coronal magnetic field plot. And this is just the magnetic field plot of the solar corona, the atmosphere of the sun. It'll show you closed potential field surface source lines in pink, open potential field surface source lines in purple if they're coronal holes, or black if they're polar potential field surface source lines. Next, we'll look at things like electron flux, which cause charging hazards of satellites when they are at very high levels. We don't see any charging hazards. We see the electron flux in a more moderate range here. There's the greater than 2 mega electron volt fluence, the electron flux over the last year. That's at solon.info. And we are going to see an increase here following that coronal mass ejection. There should be some electrons out there trailing that coronal mass ejection. So I would concur with this forecast. It's not going to be too much of an electron storm, though, as that was a dud. And it appears to be mostly over, folks. So it was a great dry run, though. Congratulations to everybody for getting the word out. There was a lot of people that have suddenly gotten a renewed interest in solar activity. Cheers to all of them, as we need dry runs in order to prepare for when really serious coronal mass ejections happen. And thanks everybody once again for that. There's the GOES electron flux over the past 3 days. And you can see this cratered here as I forecasted. Here's a visualization of the air column. It's the total electron content forecast. And nothing too crazy going on there. We show the data daily. Again, to immerse our viewers in the relevant data and to help understand the physics, as immersing yourself in data is the way to do it. There's just a diagram of the Van Allen belt and the locations of satellites such as the SDO and the Van Allen probes and the International Space Station. And we like to show this daily also, just to give folks a better understanding of where things are. For instance, the troposphere is where all your weather happens. And over there, you see that red F, right? I don't know, someplace like there. That's the F layer of the ionosphere. And again, that's where the GOES 16 makes its measurements. Here's the visualization of the ionosphere. And this is courtesy Bureau of Meteorology of Australia. Ionosphere not looking particularly anomalous today, looking pretty normal to me. It did reach 14 megahertz there briefly over the Indian Ocean. Here's the latest image coming in at 11:30 Universal Time, and we are coming at you a little late today, as I slept in for reasons that I will not disclose. All right, I'll disclose it. I dodged a bullet yesterday, as I had a broken brake line on my way home, and the brakes actually gave out, but I still had enough front brake to make it home safely. Let's look at volcanoes. Which ones are erupting? Well, Karimsky's back on the list. So Karimsky on the Kamchatka Peninsula now exploding and producing a 23,000-foot ash plume. Suwanosejima exploding as well, 6,000-foot ash plume. Popocatépetl, 20,000-foot ash plume there. Fuego exploding, Sangay exploding, Revenador exploding, and Sabancaya exploding. 16,000, 22,000, 15,000, and 27,000-foot ash plumes, respectively, at those locations. Please do not pole vault or hang glide over any of the calderas. We need the views on YouTube. Next, looking at earthquakes over the past 24. To see some deep quakes, such as this 4.3 over the Kamchatka Peninsula, or should I say under the Kamchatka Peninsula, it was at 226.7 kilometers. So no major quakes here. Once again, I would keep the earthquake risk up, because earthquake risks and protons are associated, and we've seen the first two proton events of cycle 25. And we're also seeing an earthquake drought, a massive drought of 6 magnitude earthquakes, but also, more importantly, 7, 8, and 9 magnitude earthquakes. Largest of the past 24 was this 5.5 at Kabansk, Russia, I think. Correct me if I'm wrong. And there's a deep quake in the Aleutian Islands, a 4.1 magnitude at 152 kilometers. One at Tonga, which is pretty much the deep quake capital of the world, that area north of New Zealand. Tonga and Fiji, we see more deep quakes and deeper quakes there than any place else, including record breakers. So really it's a lull in earthquakes, folks, and the lull continues. Earthquake droughts end in large earthquakes. Again, the 7, 8, and 9 magnitude earthquake drought. Have a plan if you're in a location where one may occur, and be an asset, not a liability. Next, looking at pressure maps. Here's the GFS forecast for pressure, courtesy windy.com. And that low pressure system over the Aleutian Islands is just continuing to do anomalous things, as it makes a sudden bend to the northwest. Anyway, there's where things will be at 12 noon local time for me tomorrow. And if you're wondering where I'm located, SMASH staff and I are located in Lehigh Valley, Pennsylvania. Let me just check the life of the stream here. Make sure everything is good. Thanks again for leaving comments, folks. Snitcherama, Tinman 1057, BMVR 13. And I think I've inhaled some cayenne pepper. All right, now I'm okay. By the way, I would invite you all to MANSA, which means Make America Not Suck Again. Since it's up to you, not the government. Since the government's been making it suck with all kinds of ineffective stuff because of that little thing hanging like the sword of Damocles above your head. BMVR13 says, holy perturbations. Kapow! Oh, holy perturbations, Batman. Yes. Yes, indeed. Holy Star was a planet hug. Nice idea. Intermittent puff emissions. That's me. Cheers. I would never promote something illegal, as I live in Pennsylvania. The fascist state of Pennsylvania, governed by Tom Wolfe. Feel better, Tom Wolfe. And when you do feel better, please move to Mars. I heard it's lovely this decade. I heard Mars is lovely this time of decade. And thanks everybody who's joined the Galactic Federation. Next, looking at jet streams here. Do I have the graphics up? Indeed I do. Here are the jet streams of the Eastern world, courtesy of nullschool.net. We're looking at the 250 hectopascal winds. And this is one of the best instant snapshots of weather you could possibly have. If you had to look at just one weather snapshot for the globe, the jet stream would be a good choice. Here are the jets of the Western world. Let me rotate that a little bit, as we have at least one viewer in Alaska. Shout out to Brett. And check it out, we've got the jet stream blowing backwards over the central Atlantic, as well as a strange eddy right here. Check it out. That is a weird jet stream mode right there. And we see dueling anticyclones here. A clockwise one north of the equator and a counterclockwise one south of the equator. That is an odd meteorological system right there. And that's part of the reason why we look at the jet stream daily. Because nobody else does or is able to do what our channel does. So cheers. Thanks for tuning in. Again, please share with your friends, foes, science noobs, and science pros. Next, looking at lightningmaps.org. We see quite a bit of lightning there off the west coast of Mexico, as well as over the northeastern Mediterranean. Here's the NASA GOES lightning mapper, giving you a visualization there. Nothing to write home about. No terrestrial lightning in the U.S. right now to speak of. Next, we'll look at the U.S. Doppler radar map. And the main area of action there is the entire state of Arizona. A little bit of snow and wintry mix there. A little bit of lightning in southeastern Arizona, as well as southwestern New Mexico. Here's what's going on in the cloud layer. Low clouds still remain over the Gulf and the Atlantic Ocean. Here's what's going on in the water vapor layer. And check out that wannabe anticyclone there. It's a wannabe anticyclone. Why is it going so slow? There we go. This system right here. Some massive air just making its way there across Oklahoma and Nebraska, about to collide with Missouri, which, by the way, will create clear skies most likely above your head in Missouri. And again, there's the cloud layer, and there's the water vapor. And we're going to zoom in on New Mexico, actually the New Mexico-Arizona border. So let's do that real quick. Again, pardon the delay here. Again, we are streaming live. We're also going to zoom in on that strange area of massive air. After we get that loaded, there we go. So there's the cloud layer, and you can see this looks like moisture coming in from Mexico, probably creating some quite warm conditions there. And there's what's going on in water vapor. And indeed, you can see that moisture getting blasted up from Mexico. And once again, there's the cloud layer. And there is the water vapor map. And since we have weather pornographers that view the videos, we'll show you how different the water vapor can look from the clouds by showing you this area here. So here's this area of dry massive air. And it's trying to rotate clockwise. It's just too surrounded by moisture. And there's a pressure gradient south of it, most likely there as well. We won't go too in depth into that. So the skies are going to clear up over Missouri quite soon. And thanks for flying American Smashways, folks. We've got some bonus features for you here. We've got at least one more SDO video, as well as the colorized magnetogram to show you the current high-res view of the sun. There you have that. And that sunspot's looking pretty stable here over the past 24. There is a bit of a magnetic field mix happening in front of it, but it is an alpha-class sunspot, as it only has one polarity umbra. No other sunspots. Again, the sun has reduced its activity here in the past week and indeed 2 weeks. That umbra looks like it's breaking down a little bit. I don't think we see any other sunspots here. Actually, that might be a sunspot up there. I'm not sure whether or not that will get named. Looks like a couple umbra there. Could be a beta class sunspot, very small one. And this other active region over here, not a sunspot. So we did see some umbrae there. And let's show you one more HelioViewer movie. Actually, we'll show you two of them. How about the 94 angstroms SDO video? And the 171 angstroms. Yes, yes. In the meantime, thanks to our patrons, the true source of funding for the content, please consider becoming a patron at patreon.com/smAshomash. Here's 94 angstroms. And that's 1 day of activity from the SDO. I like the 94 angstroms view. It's fantastic. And you can see a little bit of crackling of solar flares, some B-class flares coming out of that sunspot area. Again, patreon.com/smAshomash is the source of funding for the content, as we're paid practically nothing on YouTube to make the videos, so please share with your friends and foes on social media. youtube.com/smAshomash. And last but not least, here's my favorite wavelength, the 171 angstroms SDO full disk view. And we'll zoom in on the southern hemisphere to close things out. Thanks again for tuning in. Remember, stare at the sun, don't drink it. If you do, don't drive. Certainly don't drive. Don't travel to Pennsylvania, because you don't want to know what happens if you travel to Pennsylvania. Here's me vanishing. And wishing you all the best. And may that solar wind be at your back. And that covidiously absent from your location. Did Smash staff send you your check? You haven't been paid? Can we PayPal it to you? All right, now get out of here.